genetics, robotics, nanotechnology. Researchers hope machines will lead us to a brave new world. Already, robots can learn, build other robots, and cooperate with each other. It could be the beginning of a new age. It could also be the beginning of the end. Right now, we can only build robots that work with humans in control, but science is working towards machines that can think for themselves and even reproduce. Robots that can make copies of themselves without human control could one day take over the world. Hod Lipson, professor of robotics. Lipson is a pioneer in robot replication.
If this robot could make another robot identical to itself, and then those two robots can make 4 robots and so forth, these robots could fill up a space such as this here fairly quickly.
Once the first replicate is made, there's no stopping the process. But first, we've got to make them. At Cornell's robotics lab, Lipson and his team already make robots that learn, robots that build, and robots that build themselves. This is the world's first self-replicating robot. Supply it with building blocks and it assembles them to make a copy of itself. It needs Lipson and his lab techs to keep it stocked with plastic cubes. So this robot is pretty benign. To destroy the Earth, we need to develop robots that use smaller blocks and eventually individual atoms.
We've been trying to make robots made of much tinier cubes on the order of 0.5 millimeter. And you can barely see them. There's about 10 of them in this container here. We're trying to get these very small units to combine together. And the smaller they get, the faster and more easy it is to replicate.
Lipson thinks that advances in robotics will revolutionize design and manufacture. But where there's progress, there's also danger. In theory, nano-sized machines could start to replicate out of control. It's the stuff of science fiction, an amorphous mass gradually taking over the world. A mass of tiny machines that suffocate all life.
Eventually, replicating machines are made of such small matter becomes this fluid, uncontrollable goo that's been a nightmare of sci-fi.
Self-replicating nanomachines could, in theory, destroy all life on Earth. To destroy the planet itself, we need something more. To reproduce, a robot needs energy and raw materials. In other words, food. The more food there is, the more copies our robots can make. And the biggest source of food on the planet is the planet itself.
The ultimate kind of self-replicating process is something that's inspired by nature. So if we can have a machine that can essentially self-replicate using resources in the environment, food and energy, then that would be a pretty big achievement.
And the biggest natural resource on Earth is rock. Design a self-replicating robot that feeds on rock, and it has 6 trillion tons of food right under its feet. Some living creatures already use rock. Rock-feeding bacteria live in the Earth's crust, even several miles deep. But nature's rock eaters are good for the planet. They help form soil and keep life ticking.
There's a whole suite of rock-eating bacteria that we've now uncovered on the Earth, which will go and chew up and eat and use the materials in the rocks for their sources of energy and for the sources of compounds they use to build other biologic molecules. There are literally biological organisms that do just this, eat rock.
Rock-eating, self-replicating robots. But they've got to be smart. they need to cooperate. Professor Alan Winfield, roboticist in charge of the Symbrian project, to design robots that swarm like insects.
Symbrian is a 5-year project to try and build a swarm of self-assembling robots. Perhaps as many as 30 or 40 will physically join and then behave and act as a single organism. The big challenge is going to be how to get the robots to first of all decide what to be: a foot bot, or a knee bot, or a sensor bot, or a brain bot, and then work cooperatively so that, for instance, the organism can stand up and walk.
Designing cooperative robots is a challenge. And that's where these guys come in. Ants are team players. Each individual works to help the colony. Maybe we can learn from ants and take that and apply it to robots.
So these robots are behaving a bit like ants, a bit like social insects. Observing the real insects helps us, we think, to engineer artificial systems using the same principles.
Today, these are just circuits and wires. Tomorrow, there could be swarms of cooperating robots. Ants work for the good of the colony. Machines would work for us. Robot swarms could operate in environments where large machines would fail.
If this was, for instance, a search and rescue operation, and you've got perhaps 1,000 very small robots, you could tolerate a large number of those robots failing, breaking, but providing there's still a large number of them, a large proportion of the robots doing the job of search and rescue, then that's great.
We can already make robots that reproduce. We can make robots that cooperate. Put them together, and at last we may have our planet killer. Here's the math. Say each robot takes 1 day to replicate. Then after a single month, you have over 1 billion robots. After a year, you have trillions. Earth is covered with machines that do nothing but gobble rock. In the end, no more rock, just a huge ball of self-replicating machines. Success at last? Perhaps not. In our quest to destroy the planet, we've tried devouring it, incinerating it, pulverizing it, blowing it up, and breaking it down. Planet Earth is a proven survivor. It has taken everything the universe can throw at it for 4.5 billion years. And one thing is certain: we're still here.